Good day, welcome to our last review. So nahulito, so we will talk about the limit of your transcendental function. So una nating kukunin is the limit of your logarithmic functions. So ano yung logarithmic functions? Ito yung mga theorem that we need to memorize. If your base is greater than 1, then as your x approaches infinity, the limit is also infinity. If your x approaches 0 positive naman, then your limit is equal to negative infinity. If base naman is less than 1 but greater than 0, so proper fraction siya, your x approaches infinity, then the limit is negative infinity. If your x approaches 0 positive, then the limit is equal to positive infinity. Let's begin with number 1. Let's say, for example, we need to find the limit of log of x to the base 4 as x approaches 2. Kung yung x naman natin is approaching to c, then we will use direct substitution na lang. Okay? So, lahat ng x magiging 2. The function becomes log of 2 to the base 4. Then use your calculator. Log of 2 to the base 4, the answer is 1/2. Thus, the limit of this is equal to 1/2, or that is 0.5. And this is the final answer. Number 2, log of 3x as to the base 16 as x approaches negative 4. So, yung c natin is negative 4. Direct substitution tayo. So, we get log of 3 times negative 4 to the base 16 is also the same as log of negative 12 to the base 16. Then use your calculator. Log of negative 12 to the base 16 is math error. So the answer is undefined. Okay? So magkakaroon naman tayo ng undefined na sagot sa logarithm if your x is approaching to negative numbers. Okay? So from negative 1 until negative infinity, the answer is undefined. So let's say, for example, number 3, log of x to the base e as x approaches infinity. So yung base po natin dito is e is an Euler numbers with an estimated value of 71.828182. Okay? So ito yung value ng ating base, 2.7183 estimated as x approaches infinity naman. If your x is approaching infinity, we'll use the theorem. Okay? So, ito yung mga possible limits for x approaching infinity. Either yung sagot is infinity or negative infinity. So, meron tayong dalawang pagpipilian. We need to know your base muna. So, your base here is 2.7183. Is base ba greater than or less than 1? Base is greater than 1. So, we will use this theorem. Okay, na kung saan yung x is approaching infinity, then the limit is infinity. Thus, the answer for this is infinity. Next example, we need to find the limit of log of x cubed to the base 2 as x approaches 0 positive. So, before we proceed to the theorem, pwede natin itong i-simplify further. Okay? So, this is also the same as, so the exponent, ilalagay sa harap. This is also the same as 3 log of x to the base 2. Okay? Or that is simply 3 times the limit of log of x to the base 2 as x approaches 0 positive. Okay? Then hanapin natin yung value nito based on theorem. So our base here is 2. Base natin is 2. Then we will compare pa yung base. Base ba is greater than or less than 1? Greater than 1. Thus, ito yung theorem na gagamitin natin. Okay? So, our x kanina is approaching 0 positive. So, ito yung x natin. This is our base, which is greater than 1. And then, the limit is equal to negative infinity. Okay? So, we get 3 times negative infinity, or that is negative infinity. And this is the final answer. Last item, number 5. Limit of log of square root of x to the base. Ito. Wala tayo nakikitang base. Kung wala pong base na makikita sa example log, your base here is equal to 10. Base 10 po palagi yan. Okay? Kung walang nakalagay. As x approaches infinity. Okay? So, ito, pwede natin siyang i-simplify further. We get limit of log of 1/2 again. X raised to 1/2 to the base 10 again to as x approaches infinity. Then, simplify further, exponent will be put sa harap. This is also equivalent to 1/2 limit of log of x to the base 10 as x approaches infinity. Okay, ulitin lang natin. Pag wala pong base na nakalagay dito sa log, automatic 10 po yan. So, copy yung 1/2, then apply the rules. So, yung base po natin dito is equal to 10 and base is greater than 1. Okay, then our x approaches infinity. What's the answer? Base is greater than 1. X approaches infinity, then the limit is also infinity. So, multiply by infinity, the answer is infinity. And this is the final answer for number 5. And that is how you solve the limit of logarithmic functions. Now, let's proceed to the limit of exponential functions. May mga theorems then. We have here base is greater than 1. As x approaches infinity, then the limit is infinity. If x approaches negative infinity, then the limit is 0. Kabaliktaran lang po siya na kung saan yung base po natin is greater than 0 but less than 1. Let's say for example. We need to find number 1 limit of 5 raised to x as x approaches 2. Ulitin na natin kung hindi siya infinity, yung x, yung c natin, we will use direct substitution dito. Okay? So the function becomes 5 raised to 2, or that is 25, and this is the limit of your 5 raised to x as x approaches 2. Number 2, limit of 2 raised to x minus 3 as x approaches negative 5 naman. Direct substitution tayo kasi meron siyang given c, hindi siya infinite. So we have negative 5 minus 3, that is 2 raised to negative 8, or this is equivalent to 2 raised to 8. 1 over 2 raised to 8. So use your calculator. 2 raised to 8 is also the same as 256. Okay? So this is the final answer for number 2. Number 3, meron tayo infinity, so we will use the theorem. Okay? So una natin, ito, muna simplify natin. Limit of 1/2 raised to x plus 1 as x approaches infinity. Hindi tayo directly makaka-apply ng ating theorem. So we need to expand this exponential form. So that is, so limit of 1/2 raised to x times 1/2 raised to 1. Okay? Product property po tayo ng exponent. Okay? Or that is also equivalent to the limit of 1/2 raised to x times the limit of 1/2 raised to 1. Okay? Then we will simplify. Ito, pwede na tayong gamitan ng properties of theorem. Our base is 1/2. Base is in the middle of 0 and 1. And our x is approaching infinity. Thus, the limit is 0. So 0 is sukat nito, multiply by, this is constant. And the limit of constant is also constant times 1/2, or that is equal to 0. That's number 3 is equal to 0. Number 4, limit of e raised to square root of x as x approaches negative infinity naman. So, simplify muna natin to. So, yung e raised to square root of x is also the same as e raised to x raised to 1/2. Okay? E raised to x raised to 1/2. So, palitan natin. We get limit of x raised to 1/2 as x approaches negative 8. Again, yung base po natin dito is equivalent to what? Is equal to 10. Okay? Then, anong gagawin natin next? Okay, let's proceed to number 5. We need to find the limit of pi raised to 2x plus 1/2 as x approaches infinity. Okay? So, same process. Ihiwalay natin yung exponents natin. So, the function becomes limit of pi 2x approaches infinity times the limit of pi raised to 1/2 as x approaches infinity. So, ito, pwede natin itong i-dissect further. So, we get this multiply by the limit of pi raised to 1/2 as x approaches infinity. Then, simplify na natin yung pi raised to 3. That is equivalent to 31 estimated. So, we get 31 x approaches infinity times the limit of, so this is constant, so 1/2 or 0.5, so the answer is 1.77 estimated as x approaches infinity. Now we will apply the theorem natin kanina. So our base is 31 and 31 is greater than 1, and our x approaches infinity, and then the limit is also infinity. So the answer is infinity. times, ito naman, this is constant. The limit of all constants are constant. So we have 1.77. Infinity times 1.77 is equal to infinity. So that's how you solve for the limit of exponential functions. Now let's proceed to the limit of trigonometric functions naman. Last, transcendental functions. So before we proceed to these items, ito dapat yung mga dapat nating matandaan. Okay? So limit of sine x as x approaches c, may given siya is equal to sine c by direct substitution lang siya. Okay? Pero kung yung limit ng sine x or any trigonometric functions as x approaches infinity, always undefined yun. Okay? Kahit cosine x to, cotangent x, tangent second or cosecant. Okay? And then ito naman yung mga special limits natin. Limit of sine x over x as x approaches 0 is equal to 1. And the limit of 1 minus cosine x over x as x approaches 0 is equal to 0. Special limit. Ito naman direct substitution, always undefined naman if x approaches 0. Infinity rather. Let's say for example. So we need to find the limit of sine x as x approaches 2. So c po, meron tayong value. Direct substitution tayo. That is sine 2. Okay, and sine 2 is equivalent to what? Sine 2 is equivalent to estimated 0.03490. Okay, so ito yung limit ng ating sine x as x approaches to 0.03490. Number 2, limit of tangent x as x approaches negative 4. Substitution lang din siya. So we get tangent negative 4. And the answer is negative 0.06993 estimated. And this is the limit of your tangent x as x approaches negative 4. So how about number 3? So dito mag-apply tayo ng special limit. But before that, we need to see to it that etong angle is also the same as your denominator. So dapat parehas sila. So in our case, 5x is different from 7x. So anong gagawin natin dito? So yung 1 minus cosine 5x over 7x, multiply po tayo ng, yung goal natin dito is magkaroon ng 5x dito. So para magkaroon ng 5x, we will multiply the fraction by 5 over 5, or that is 1. Okay? Then, yung gagamitin na lang natin is 1 minus cosine 5x times 5x over, so ito we can use distributive commutative property of equality. Okay, pwede natin i-swap. So we get 5x over then 7 naman sa kabila. Then apply the special limit. Yung 1 minus cosine 5x kanina is equivalent to 0, right? So this is equal to 0, and this is equal to what? To limit of times 5x over 7. So ito magiging 0 din siya by substitution. Then answer is 0. Okay? So para mas madaling maintindihan yung special limits, if this is the function involved over your x, okay, the answer is always 0 pa. Okay? Kasi when we multiplied any number by this limit as x approaches 0, which is 0, the answer is always 0. Right? So yan. So proceed tayo sa number 4, limit of sine 6x over cosine 4x as x approaches 0. So dito, we will use special limit of sine x. Okay? So ganun pa rin yung process. Maghahanap tayo ng number na i-multiply sa function para magkaroon po tayo ng 6x sa baba. So in this case, we will multiply the function by 6x over 6x. Okay? Then the limit becomes sine 6x multiplied by 6x sa kabila. So ito, swap pa rin. Okay? We get 6x. Ito naman, cosine 4x. So ito na yung ating special limit, which is equivalent to 1 times. Okay? So what's next? Ito naman, and this will become what? This will become 6 times 0 over cosine of 4 times 0. Then we will simplify further. So this is equal to 1 times 6 times 0 is 0 over cosine 4 times 0. So cosine 0, cosine 0 is equivalent to 1. So this is equal to 1. So 1 times 0, or that is equivalent to 0. Thus, the limit of this is equal to 0. So let's proceed to number 5. So the normal limit of 1 minus cosine 2x over sine squared 2x as x approaches 45. So dito, we will not use the special limit since your x is not approaching to 0. So anong gagawin natin? We will use direct substitution. So the function becomes 1 minus cosine 2 times 45 over sine squared times 2 times 45. Okay, then we will simplify. We get 1 minus cos 2 times 45 is 90 over sine squared 2 times 45 is also 90. Okay, so yung nasa baba, we will use the identity loss or the powers of trigonometric functions. Okay, so so sine squared theta is also equivalent to 1/2 times the 1 cosine 2 theta. Okay, so yun yung sagot. Then so ibig sabihin yung sine squared theta is also the same as what? Is also the same as, so copy lang muna yung nasa taas. So we have 1/2 times 1 minus cosine 2 times what is our theta again? 90. So yan, simplify further, we get 1 cosine 90 over 1/2 1 minus cosine 90 times 2 is 180. And then use your calculator. So cosine 90 is equivalent to 0. So we get 1 minus 0 over 1/2 1 minus yung cosine 180 natin is equivalent to negative 1. Then we get 1 over 1/2. Negative times negative is positive. 1 plus 1 is 2. So cancel, or that is equivalent to 1. So therefore, the answer for number 5 is equal to 1. So that's how you solve the limit of trigonometric functions. See you.